Hello. In this video we compare C++ and Rust backend frameworks for web applications. More specifically, we will be looking at which language and backend is better by analyzing the following criteria: ease of integration with the language, build times including the entire application and its dependencies, development activity on the repository, documentation and development time, and last but not least, performance in terms of requests per second using a tool called Drill. Deciding the best framework to develop a web app backend can be difficult, especially when there are so many choices for each language. C++ is not necessarily known for being the most backend-friendly language out there, as it has very few syntactic sugars that make it easy to achieve common patterns in web development, and you may find yourself writing a lot more code compared to other languages. Rust, however, is a modern language with the promise of safety out of the box. And frankly, Rust is also a nicer language to write in and easier to understand than C++. But will all these so-called zero-cost abstractions prove better than C++ for a simple web application backend? Let's find out. Let's begin with the web app architecture. For this comparison, I really wanted to focus mostly on the frameworks themselves. Therefore, the actual web app's architecture is very simple. It's simply a key value store with 4 endpoints. The first one is a post endpoint item/name/value to store an item with the given name and the value to the key store. The second one is a get endpoint item/name to get a possible value stored in our application. The third one is a delete endpoint item/name that deletes a value that was previously stored. And the fourth and last one is a get endpoint items that shows all the items and values currently stored in the application. The implementation is also very simple. The main logic is to manage a thread-safe map that is storing all the key value pairs, so nothing fancy there. Now moving on to the choice of frameworks for each language, beginning with C++. I was actually surprised as to how many web frameworks are actually available for C++. After looking at a few different C++ web framework recommendation articles, a select few kept popping up: Oat++, Dragon, and Crow. The three named frameworks all seem to have a good following base online, plus they all seem to have a fairly active code base. Dragon and Oat++ were the most popular frameworks by far, but I was drawn in by Oats++, multiple recommendations on Reddit and random articles online, so I picked it for this video. Oat++ is a lightweight C++ framework for web servers, and it promises to be a highly scalable and resource-efficient tool for the creation of backends for web applications. All of this with zero dependencies. And you heard that right, no dependencies are needed to build this library. But does it feel like writing backends for breakfast with Oat++? We'll find that out shortly. Rust also has quite a few popular web server frameworks in active development. For example, a simple Google search may suggest the following: Actix Web, Hyper, which is a lower level choice, Axum, which uses Hyper internally, and Rocket, which also uses Hyper internally. Since one of the premises of this video was to compare the learning curve for a complete beginner in the framework, I chose Rocket as I already have some experience writing Axum at work. Rocket has quite a few dependencies itself, and some of those are quite usefully exported so that you can use them within your project. For example, you can use SERD for serializing and deserializing structures into things like JSON, YAML, TOML, and etc. Now for the first measure, development activity, beginning with Rust and Rocket. Rocket is quite a hot library right now, and the popularity has exploded like a firework in the past few years as more and more people started to use Rust. For a framework first released back in 2016, it still has the momentum of a new popular Rust library. So basically, I'll give Rocket a 10 out of 10 for development activity, as the GitHub repository is blowing up with feature requests, issues recorded, and the PRs to address all of these things. Surprisingly, Oat++ is actually younger than Rocket. It was first released back in 2018, making it 5 years old at the time of recording this video. Again, this framework is still very popular among C++ developers. The GitHub repo contains a lot of new issue discussions, feature requests, and PRs implementing new fixes and features. Since this library is younger than Rocket and the number of contributors and commit frequency is also lower than that of Rocket, I'll give Oat++ an 8 out of 10 here. On to the second measure, integration. How easily does Rocket integrate into Rust projects? If you have used Rust before, you know that this is a trivial step. Rust's Cargo makes it extremely easy to add third-party libraries to your project with a simple call to cargo add. Rocket is no different, so 10 out of 10 here. In comparison, Oat++ is a little more difficult to integrate. If you have written C++ applications in the past, you know that including third-party packages feels like hell sometimes. Luckily, I used Conan v2 to manage my dependencies here, and of course, Oat++ was available in the Conan Center. If you're interested in learning how Conan can help you including third-party libraries into your C++ projects with a few lines of code, watch this video where I explain how Conan works in under 30 minutes. However, since Oat++ is inherently harder to include as C++ does not have a built-in package manager and I had to include Conan into my build, I can only give Oat++ a 5 out of 10 here. Next measure, build times from a clean state. Before I get into the nitty-gritty of this, I just want to clarify how I've acquired the data for this section. To get the average build times, I did a clean build for each project. In Rust, this simply means running cargo clean and then timing the cargo build -- release command over and over again. In C++, this was a little bit harder. We have 3 stages to our build here, one of them being the dependency build with Conan, the other being the CMake configuration, and the last one being the CMake build. For the Conan build, I basically told Conan to build all the dependencies from source, then nuking the Conan cache to make sure nothing is left out of the next timed build. For the CMake stages, I simply deleted the build directory for my project. Since I am not using Ccache or anything fancy to cache builds, that should suffice on making sure we build from zero every time. Now, Rocket has a lot of dependencies, so building an app with Rocket for the first time can take longer than expected. The average build time for me was about 51.55 seconds. C++ blew my mind. I initially did think it would be somewhat faster than the Rust build since Oat++ has no build dependencies, but I also thought that having a separate package manager to the language would compensate for the gained build time. However, even when we consider the Conan build time, which has a bunch of Conan internal calculations, and the CMake boilerplate time, we still had a mean build time of 24.13 seconds, less than half of Rocket's build time. This is even more impressive when you realize that FMT was also included in the build, which is a very lightweight library indeed, but likely added a couple of seconds to the overall build average time. For this reason, C++ and Oat++ get a 10 out of 10 in this measure. On the other hand, Rust and Rocket get a disappointing 5 out of 10 here. Why is Rocket's build time so slow? Well, I've noticed that it has too many dependencies. Maybe they could do with cutting down that number to make the build time a little faster. After all, this is a tiny project compared to real-world apps, and it still takes over 2 times longer than a not so popular C++ framework. Now, on to looking into documentation and the learning curve. Beginning with Rust and Rocket. This is perhaps the criteria where Rust and Rocket shine the most. The documentation and examples for Rocket are very complete, and all the quirks and tricks of this framework are fully documented somewhere on their online documentation. As it was my first time using Rocket to create the necessary endpoints and handlers, I hardly got stuck on the implementation. In addition, the Rust compiler is usually a lot more helpful than the C++ compilers, especially when it comes to errors in macro expansions and template structures. The whole app took just under 2 hours to complete. At the end of the project, it really didn't have that many lines of code, but this did include research into the framework and the time taken for reading the documentation. Taking these points into account, I can give Rocket a shiny 8 out of 10 here. This may seem a little bit low, but that's because there are still areas I believe the documentation could improve. For example, it was difficult finding out how to return different custom error types from the endpoints, such as results of JSON, so I had to really dig deep in the documentation sometimes. Now in contrast, Oat++ was a little bit of a nightmare. Oat++ does have a shiny documentation page, but it's nowhere near as useful as Rocket's docs. For instance, the beginner tutorials are a little fragmented and hide a lot of the detail that are going to be needed as soon as you do anything more complex than their Hello World project. For example, I struggle to find basic documentation on things like adding new endpoints, passing values to endpoints handlers, returning JSON as the content type, and so on and so forth. This is partially due to Oat++ having a different architecture to other frameworks, and I wasn't used to their way of using controller classes to manage the entire web server, component systems to manage resources, and DTOs to manage responses to users. I wish they had renamed their doc pages to reflect what the user may be looking for. So instead of having a data transfer object page, why not call it something like handling serialization of responses instead? Also, don't even get me started on the lack of documentation for multiple macros that, if used properly, make the code a lot easier to read and develop. Overall, the Oat++ project took a couple of streams and just over 3.5 hours to complete. For this reason, I'm sorry, but I'll have to give Oat++ a 5 out of 10 here. Let's move on to performance now. As a disclaimer, I am not a backend engineer, so I understand that the performance tests I've run don't provide the whole picture. For example, I run all of these tests locally, accessing each backend through the local host. Therefore, these tests kind of lack the data on how well each backend scales in the cloud, as well as the network side of things. We simply look at the number of requests per second and the memory consumption when running on WSL2. So take this measurement with a pinch of salt. To measure performance, I've used a very simple Rust tool called Drill. Drill allows you to bombard web servers with many requests per second, where you can define which type of data to send to an endpoint, number of iterations, concurrency options, and etc. In essence, I hit a few breakpoints over and over again. Beginning with the endpoint to add an item, we add 2,000 different items, each item having a name based on the iteration. Following that, we get each of the newly added items as well as extra item names that were not added through the get endpoint. This endpoint is hit about 10,000 times. And following all of this, we hit the get all items endpoint to test how each server backend handles returning a very heavy load to the client. This is done about 100,000 times and is perhaps the most interesting performance test here. Starting with Rust and Rocket, the web server actually performed quite well when looking at the number of requests per second that it could handle. The complete drill test takes around 134 seconds and it could handle 834 requests per second on the previously mentioned test case. Over to C++ and Oat++, things didn't go so well at first, as the initial test took about 164 seconds to complete, resulting in the number of requests per second being 681. I quickly figured out that the use of stud map was probably the cause of the slowness when compared to the Rust web server. This is nothing new, Rust has a more modern and fast standard map implementation. So when I switched to stud unordered map, things got even worse. The total test time jumped to 166 seconds, making the total requests per second come down to 672. Clearly, the C++ standard maps are trash. Since I was using Conan, I quickly added a dependency on dense map by a guy called Martin Leitner Ankel, which is a map implementation that has recently been showing up on most benchmarks as one of the fastest C++ maps out there. This did actually help, making the total test time come down to 157 seconds and the requests per second to 711. Still, Rust seems to be way more efficient, right? Well, when you consider memory usage and CPU usage, perhaps not so much. C++ and Oat++ CPU peaked at 70% usage, while Rust CPU usage peaked at 86%. Similarly, C++ memory usage peaked at 6,330 bytes in memory, while Rust's memory peaked at 7.1K, which is around a 13% increase. Not so much. I also noticed that Oat++ was a true single-threaded backend framework, as it only spawned one OS thread for the whole test. Rocket spawned an OS thread per core on my machine, which ended up being about 12 overall. This is probably because of the nature of Tokyo, the async backend used by Rocket, which, when combined with the increase in average CPU core usage, this would certainly increase the energy bills over the C++ backend. Also, I do wonder what happens when the same app is implemented in async Oat++ mode, as the library does support this, but unfortunately I did not have time to implement it and find out. For this reason, I will give the Oat++ backend implementation a 9 out of 10 and the Rust one coming closely behind with an 8 out of 10 here. Now lastly, for a bonus measurement, we've got the binary size. One minor thing that I did notice was the overall size of the application, which indicates how bloated the framework is. The C++ and Oat implementation was extremely light, coming in with a featherweight of 1.1 megabyte for the final release built application. On the other hand, the Rocket application ended up being a whopping 9.3 megabytes for the final release build. This is nearly 9 times bigger than the Oat++ application. So if there is something Rocket can learn from Oat++, it's how to reduce the bloat, I guess. So for this reason, Oat++ gets a 10 out of 10 here, and Rocket gets an 8 out of 10 here. Now, to conclude this whole thing, I have really enjoyed researching and measuring these two languages and the frameworks against each other. On one hand, we have Rust, a very modern systems language with an amazing embedded build system where you can include almost anything with a simple terminal call to cargo. On the other hand, we have C++, which is a mammoth of a language that has incredible hardware portability and many years of history. I've got to say, I was extremely surprised at how well the C++ framework seemed to perform, considering that most of the web framework development and optimizations are done in different languages nowadays. Without further ado, here are the overall results and my honest opinion on which language framework can give you more bang for your buck. Rocket and Rust totaled an astounding 49 out of 60 in the measures we considered. The framework and dependency management really makes the development time faster, and coupled with the easy to read documentation, this framework is a very strong choice for anyone who's serious about developing backends. Oat++ and C++ totaled an impressive 47 out of 60 in the same measures. Again, I was actually very surprised at how close this combo came to the Rust counterpart. I pretty much expected C++ to fall way behind Rust for the web development application. But which language and framework would I pick? Well, it's not that easy of an answer. For the most part, I do agree with the data presented in this video. Rust and Rocket should be a preferred choice over Oat++ and C++. This is because I don't really value each of the measurements equally. Development time for me is king, and if that means taking a little bit of a hit in the performance or eco-friendliness, so be it. We live in a time where getting your ideas out faster is much more valuable than releasing a perfectly optimized version of it. Therefore, considering the fact that it does unfortunately take a lot longer to develop a C++ backend compared to a Rust one, I would pick this language framework combo 9 times out of 10. However, it's not to completely say that I would never pick the C++ framework. For example, if the whole stack of my project was C++ and I was tasked with adding a simple REST API for a reason or another, I would probably stick to the same stack tech and develop a C++ backend, as it wouldn't add any more tech dependencies and a huge build time difference. Now, would I pick Oat++ specifically? I am not too sure. After I developed this test app with Oat++, I realized that the macro-based syntax is very confusing, and I wasn't a massive fan of the controller-based architecture. There is another C++ framework that is just as popular with a much more modern syntax, Drogon. I only realized how much nicer to write Drogon is after I made this video, so I don't actually know whether it is better performing than Oat++. But in short, if you're creating a new project and want to use either C++ or Rust for backend development, pick Rust as you will have a nicer development time. So what do you think? I'm keen on finding out your opinions on C++ backends and whether you had a good time developing a server-side application in it. Did you find it easier, harder, or about the same difficulty as developing a Rust web application? Thank you very much for watching, and don't forget to drop a like, and I'll see you guys in the next video. Bye bye.